Draw the shear and moment diagrams for the beam. For this problem, we're going to use graphical method, and B is a pin connection. And we don't need to worry about horizontal force on B because there aren't any horizontal forces acting on this beam. Now to find our other B forces, we just have to take moment about the point B, and this will give us our reaction force for AY. We're going to have clockwise 300 pounds, 8 feet away. And then we have counterclockwise 500 pounds, 8 feet away. And then clockwise AY, 16 feet away, all equals to 0. Solving for AY, we get our solution as 100 Newton. Now we can sum the forces in Y direction. Just find our solution for BY. So we're going to have 100 Newton, negative 500 Newton. Pardon me, all of these are pounds. Pound, pound, and then negative 200 pound, negative 300 pound, positive BY, all equals to 0. Solving for BY, we're going to have 900 pounds as solution for BY. And now we can start drawing our graphs for shear and moment. We're going to begin with shear. For shear, we're going to begin at 100 pounds. Nothing's going to happen till 8 feet. Then we're going to go down till negative 400. Then nothing's going to happen for till 8 feet. And at that time, we're going to move up by 700 pounds, which will bring us to 300 positive. Then again, nothing's going to happen till 8 foot. And then we're going to come down by 300, and we're going to come down to 0. Now we're going to move over to moment, and we know we did our shear diagram correctly because we reach 0. As long as we reach 0, we know that our diagram is correct. Okay, and for a moment, we were going to begin at 0, and then we have this area here, which is 100 times 8, so 800 positive. So we're going to go up 800, and we're going to have first degree curve or first order curve. Then we have a negative area. It's going to be negative 400 times 8. 4 times 8 is 32, so 3200. So we're going to go downwards 3200. So 32 take away 800 is negative 24. So we're going to come down to negative 2400. And this is also our first order curve. And then we're going to go up 300 times 8. So 3 times 8 is 24. So we're going to go up 2400, which will bring us to 0. And this also tells us that our moment. Draw the shear and moment diagrams for the beam. So at A, we're going to have a vertical force, and at B, we're going to have vertical force, but not the horizontal, because horizontal will be 0 because there isn't any other force acting on it. And before we start drawing, we need these forces, external reaction forces, to determine our starting and ending point for the diagrams. To find a solution for AY, we have to take moment about the point B. We're going to have counterclockwise 2k, and it's 4 feet away. Then the other one is 8 feet. The other one after it is 12, and the one after is 16. And finally, we have clockwise AY, and it's 20 feet away, all equals to 0. Solving for AY, we get our solution as 4k. And then for BY, all we have to do is sum the forces in Y direction. So we're going to have 4k, and then negative 2 times 4k, pardon me, 2k times 4 and positive by all equals to 0. And so this by is going to be 4k. And now we can begin drawing our shear and moment diagram. So for shear, we're going to begin at 4k. Nothing's happening for 4 feet. Then we're going to go down 2k, come to 2k. Then for 4 feet, nothing's going to happen. Then we're going to come down to 0. Then nothing's going to happen for another 4. Then come down 2k. It's going to be negative. Nothing's going to happen for the next 4. And then we're going to come down another 2k, come down to negative 4k total. Then nothing's happening for another 4 feet. And then finally, from by, we're going to go up 4k, come down to 0. This means our diagram is correct. Now we can start drawing our moment diagram. For the moment diagram, we're going to begin at 0. Then we have this area, which is positive. So that means we're going up. So it's going to be 4 feet and 4k. So that's 16. So we can go up 16. Going to be first order curve. And then we have 2k for 4 feet. So that's going to be 2 times 4, which is 8. So 8 plus 16 is 24. So we're going to go up to 24 straight. And then nothing's going to happen. Going to go straight for 4 feet. And then we're going to start to come down. So it's negative 2k for 4 feet. So that means we can come down by 8. We'll come down to 16. So not negative 16, positive 16. That'll be first order curve again. And then finally, this lap is going to be 4 times 4, which is 16, and brings us to 0. So that means our moment diagram is correct as well. The flooring system for a building consists of a girder that supports laterally running floor beam, which in turn support the longitudinal supplies for the floor slab. Draw the shear and moment diagram for the girder. Okay, so this means this girder is going to have load here, here, then one load here, here, and another load here. And then it's also going to have one AY and one BY. Let's find AY and BY first because it's easier. So for BY, all we have to do is take moment about AY. We have to take moment about the point B. We're going to have counterclockwise 20k times 5 feet. And then we're going to have counterclockwise 4k times 18 feet. And finally, clockwise AY 20 feet away. All equals to 0. Solving for AY, we have our solution as 6.88. Okay. And then for our BY, we simply have to sum the forces in y direction. We're going to have 20k, negative 4k, positive 6.88k, and then positive by, all equals to 0. Solving for by, we have our solution as 17.12k. Alright, now that we have that, as the question states, these beams have the load on the girder, so therefore we have to find the distributed load from the floor slab to the girder, from the floor slab to the beam, and then from the beam to the girder. For our first load, we'll have to divide it by 2 divided by 5 times 4. This gives us, on the left hand side, we can have 1.6k, and the remaining 2.4k is going to be on the other side. Pardon me, it'll be the other way around. So 1.6k will be on the girder on the left, 2.4k on the girder, that's on the left, and 1.6k on the girder that's on the right hand side of the point load. And now for next point load, it's going to be divided by 2.5 feet, so 2 times 2.5, which gives us 5K. And then the middle point load of the distributed load is going to be 10K. And then the last one is going to be same as the initial load, which is 5K. We have already found AY and BY. And now we can draw the shear and moment diagram for the girder. Beginning with the shear, we're going to begin at 6.88K. Nothing's going to happen for the next 5 feet. Then we're going to go down 2.4. Just going to bring us to 4.48. Then again, nothing's going to happen for the next 5. Then we're going to go down 1.6K to 2.88. Then again, nothing's going to happen for the next 5 feet. Then we're going to go down by 5K. We're going to come down to negative 2.12. And then again, nothing's happening for the next 5. Then we're going to go down by 10. We're going to come down to negative 12.12. And then again, nothing's going to happen till the end, where we have conflict between By and the point load on top. Subtracting these, we get positive 12.12, which takes us to 0, and that confirms that our graph for the shear was correct. Okay, and now for our moment diagram. Our moment's going to begin at 0. Then we need the area of the first 5K, so it's going to be 6.88 times 5, which is 34.4. Going to be first degree. Then we're going to need the area of the next 5 feet, which is going to be 4.48 times 5. It's going to be 22.4 plus our 34.4 comes up to 56.8 first degree order or first order curve. And then again 4.22 times 5, that is 14.4, and plus our initial 56 takes us to 71.2. And that was also our initial, the first order curve. Now that we have done that, we have a negative area, so going to be negative 2.12 times 5 is negative 10.6. Take away 71.2 takes us to 60.16. And it's again first order curve. And then the next area is negative as well, and it's going to be negative 12.12 times 5, which is 60.6 negative, and this brings us to 0.